All right, just give me a second. All right, cool. Okay, good afternoon, everyone. Today, my talk is going to be about auth, OAuth, basically. And the reason why we want to understand OAuth is because when you do any APIs, like REST or GraphQL or anything like that, the first challenge or hurdle you'll always come across is authentication, because, well, otherwise you can't even get access to the other APIs, right? So that is why I am focusing on auth today, and that's the topic I'm talking about. Essentially, what I'm going to do is to give you an understanding of what OAuth is and how it works. So you can do your own OAuth implementation without using libraries if you choose not to do so. Of course, like Auth0 makes things a lot easier. Supabase makes things a lot easier. But I'm more of a fundamentals guy at this point, and I want to make sure the black box, I kind of understand what's inside the black box. So I hope to bring that to you today. Let me talk a little bit about myself before we begin. I am Zell. I have a blog at zellwk.com. And I primarily write about HTML, CSS, JavaScript, and some Node and MongoDB. Not much at this point, but these are the things I cover, generally speaking. And I take a lot of time to write huge-ass courses. So like Learn JavaScript is a course focused on vanilla JavaScript. It's 300+ lessons long, like for example, like huge-ass courses. And I have one focusing on asynchronous JavaScript, and OAuth part of things, because it's related to APIs, falls under one of the modules I teach inside here. So that's kind of what I just want to talk about at this point. And so what is OAuth and why? Why do we use OAuth in the first place and not just like simple username and passwords? So OAuth stands for Open Authorization. It is a protocol for you to do authentication and authorization. Authentication meaning, okay, are you who you are? You know, like Thai, are you Thai versus like am I impersonating Thai, for example? So things like that. And authorization is basically permissions. Do you have the permission to do the thing that you are supposed to do? If I do not allow you the permission, then you cannot do it. So that will be authorization. The good thing about OAuth is that it uses tokens instead of passwords. So the good thing about tokens is that you don't have to remember passwords anymore. That's one thing. The second good thing about tokens is that it allows for things like login with GitHub, login with Twitter, and stuff like that to happen, because we pack all the login information into a string. So a token is kind of like a string. You can see it over here like XX token, similar looking string like that. It contains information about the authentication itself. It contains information about the authorization as well. So that string is decoded and encoded, and nobody can understand what the hell is going on, so it will never be stolen in a way. Even if it's stolen, you can always refresh it, and you get a new one. So that's what it does. And just to sum up why OAuth is tokens are more secure, because people don't have to remember their passwords anymore, and then, you know, like how people do, they always forget their passwords. So they don't have to write it down in a notebook and chuck it aside. No more of that nonsense. We just use tokens. Except the tokens are automatically generated, so they don't even have to care about saving it anywhere. Except we do. Like all of the work falls on us, right? Then having a token allows you to log in with identity providers, and it allows you, the user, to specify whether you give them the permission to access your email address, whether you can access, like allow them to post to your Twitter timeline, for example, things like that. So that falls under the authorization scope. And yeah, people don't have to remember passwords when they start logging in with Google and Twitter and all that stuff, and then they start forgetting their passwords. Good job, everyone. So how do you use tokens? The simple way is to use a bearer token. And to do that, you can use plain old fetch, the normal fetch, and you use an authorization header with bearer. So that's a boilerplate code that you kind of have to write every single time you write token-based or bearer-based authentication. So what I like to do is I like to reduce this boilerplate code. So I kind of came up with my own wrapper library similar to Axios. I call it ZLFetch for short. And it basically takes away the need to write another then call. It takes away things like setting content type to application JSON because that should be the default at this point. It takes away the need to stringify the body content so that it automatically converts objects into JSON, for example. And the last thing is, well, I don't have to write bearer authentication, I just write auth. Awesome. So that's kind of like what the library does. You can look at the GitHub if you want to find out more about it. So today's talk is not about this library, so let me move on. Now, how do you get access to these tokens? We've been talking about tokens and tokens and tokens. Well, under OAuth, there are 5 ways to get these access tokens. That is client credentials grant, authorization code grant, proof key of code exchange, refresh token grant, and device code grant. Now, all of that sounds so complicated, right? Especially the word grant. It sounds like I'm giving you something so important. Like you're applying for a grant from Singapore for money or something like that. So the way I like to think about it is you cancel the word grant, you replace it with the word method, and it makes a lot more sense in English. So, but we like fancy terms, so let's stick with grant. That's the official language, so let's stick with that, all right? So the next thing you also have to understand when you do authentication is the difference between a public client and a confidential client. So a public client is that your source code will be exposed to the public. So HTML, CSS, JavaScript on the front end, it will definitely be exposed. Do not ever put your passwords there because they will be stolen and people do bad things with it, right? So that's kind of what falls under public client. Now, mobile apps also fall under public client because you can compile your source code and then someone can dig through the source code and find your secrets. I have no idea. I have no idea why or how or why someone would do it, but it is possible, so try not to do that. Now, the other side is confidential client, and then that means the source code is not exposed, which means practically it's just all your server stuff. It's all hidden from view, nobody knows what the hell goes on in your server. Okay, so have an idea about the 2 of them at this point. Now, for all the 4 grant types, right? For 5 of these grant types, 4 of them can only be used with confidential clients. Client credentials, authorization code, refresh token, device code. So these 4 will be used with confidential clients. The only one that can be used with public clients is this thing called proof key of code exchange. So we'll cover each one of them and what they do. So I'll cover 1, 2, 3, 4, but I will leave device code grant out of this talk today because, well, generally we don't really need to touch that. That's kind of like, oh, if you have a TV and then you need to log in with the TV, that it's a little bit hard to use your keyboard, right? So that kind of allows you to transfer to your phone and then you log in with your phone instead and how that goes on and yada yada. We're not going to go into the implementation details of that today. But we are going to go into the implementation details of the rest of them so you have an idea about how it does or how it looks like underneath the hood of things. Let's begin with client credentials grant, which is the simplest of them all. So client credentials grant can also be called two-legged authentication because it is an interaction between 2 parties, your server and the API server, whatever it is, and then the 2 of them are playing games with each other. So nobody else is involved, that's why two-legged authentication. The idea is that you have a client ID and a client secret, so 2 values. Remember that whenever you see secret, always put that inside your server because you don't want the secret to be exposed as like your password. So what you do is you send the client ID and client secret in for an access token. And the good news is we don't even care about client credentials grant in a practical term. Why? Because if you're using like a server, you should probably be downloading some sort of client library from the server that you're working with. Like Stripe has its own client library, Google has its own client library, blah, blah, blah. So most of the time, the client library takes care of the client credentials grant for you. So you don't have to worry about it. And what you do is you initialize it with your API key and API secret, and then you call the methods, done. And that's what it does. But for the interest of like figuring out what goes underneath the hood, right? So like this is how it looks like. Basically, you need to send a post request to a token endpoint, which usually is like authorize/OAuth2 or whatever, something like that. And you need to set the grant type to client credentials. You need to send in your client ID. You need to send in your client secret. And an optional scope value, which I will talk about in a bit. Okay? Now, this is the standard that is given. But, okay, lots of buts. There are always non-standard stuff going on in the dev world, all right? For example, Google asks for a key file instead of the client ID and client secret. So you kind of have to download that JSON file and add it to your project. Facebook uses a GET request instead of a POST request, which is interesting. And Twitter requires you to send in a basic authentication with a client ID and a client secret, but that values are being sent in the body as well. So things like that do happen. You kind of have to look at the docs in order to figure out what the API requires. So don't take it as this is the standard thing and everyone should or is already applying it in that standard way. So just a heads up when you're dealing with the lower level stuff. Now, here's an example where Google requests for a key file. So I just wanted to put it there just to show you. Now, so long story short, for client credentials grant, forget about the OAuth part, just use client libraries. End of story. That's the easiest way to go about doing it. The story changes a little bit if you start doing three-legged auth. Three-legged auth meaning there are three parties to the equation, three interactions. There's the user, there's your server, and then there's the API server, like three people. And basically what happens is, you send you send the user to the API server to log in, and then they log in, the API server gives your app something, and then you kind of have to figure out whether that's okay. You send it back to the API server. So the two of you start talking, and eventually you say, okay, fine, you are logged in. Then it goes back to the user. Essentially, it's something like that, but we'll walk through the flow together. Now, three-legged auth allows you, like I said earlier, to log in with an identity provider. Identity provider meaning someone that allows you to hold an identity. Like GitHub, you can log in with GitHub, you can log in with Facebook. Each one of them has an account that says that it is you. So that's how it is. And you can perform actions on your server for the user's behalf if you use that kind of API. So those are the two main cases for three-legged auth. And to implement three-legged auth, you can use Authorization Code Grant, you can use PKCE, or Refresh Token Grant. But Refresh Token Grant is I kind of lump them together, but it's not exactly like you can use it straight away. To do Refresh Token Grant, you need to use either Authorization Code Grant or PKCE first. Then you get the refresh token from that. Then you can use the refresh token grant. We'll walk through them step by step. So the first thing is authorization code grant. That's like the simplest to understand at this point. There are a couple of steps to be able to use authorization code grant. The first is to create an app with the identity provider. That's like a must thing to do if you're doing any OAuth related stuff. So what this means is you kind of need to go into the developer portal, make an app. Then you generate a login link, and then you let the user log in, and then it sends you back to a callback URL, and you do a post request. Well, we'll walk through this with some code examples. So first, you create an app with the provider. So here is an example where that's the example for GitHub. And essentially, I place some random values in there. The important thing to know here is the application name. So like the name of your application. People will see that before they authorize it. And the second most important thing is this thing called callback URL. Because what happens is that when the person is authorized, the identity provider will send that request to the callback URL that you specify. So those are the two major things you need to take note of. all the other stuff are random values that you can roughly fill in, and it doesn't really impact things that much. Second is to generate a login link that allows the person to log in at the identity provider. Most of the time, this will be simple. You need the endpoint, which in this case looks like github.com/login/auth/authorize, something like that. Then you need a client ID, which tells GitHub that this is your client, so that it can show your login thing. And you need a scope as well. That's optional. Again, I'll talk about scope in a bit. Now, sometimes it gets really complicated, like the one with Twitter. You have the link, you have a response type, you have a redirect URI, you have like all the other stuff is related to PKCE. So this is an example of the link that you need to generate as part of the process. Now, the second step is to put this link into the HTML. You can either put the entire link into the href directly, or perhaps a better way is to link to your own backend and then redirect from your backend. Notice that we have to use our backend here anyway. Even if you're a front-end developer, you need a server because we will be handling client secrets. So we need a server, like it or not. So that's how it is. So we redirected the person there, and then they will see a page like this where you authorize this, the name of the app. So that's why the name is important. And then if they click authorize, they will go back to this thing called, to the callback URL that you specify. Notice that the callback URL is a little bit different because when I took the picture, I forgot what I wrote previously. So this should be the actual callback URL that you put in earlier, but the subsequent images use this one. So yeah, take it with that's a mistake I made previously. Okay, so essentially when GitHub or any other identity provider sends the information back to your callback URL, what you need to do is to extract the code query parameter. And you can see that it's here, like question mark code blah, blah, blah. So you can get the query parameter in there. Then you use the query parameter to send a post request to the identity provider again. So there's a lot of ding dong back and forth. And this time around, you send in the client ID, the client secret, and the code. And they will, at this point, give you back the access token that you're looking for. And at this point, you can use the access token to log in and perform any API request with this access token as on behalf of the user. So you can use that. And you want to save this access token somewhere on your computer. No, somewhere on the user's computer. And usually it is going to be in local storage or cookies. Now, if you have read stuff about this related to security before, you know that there are lots of opinions about whether you should save in local storage versus you should save in cookies. One is easier, one is more secure, blah, blah, blah. I've done my research, and both of them are fine. You just have to know the different constraints about each of the platforms and why. I do intend to write an article about it. I have no time at this point, but if you want to get the article when I release it, you can go to my blog, sign up. I'll let you know as soon as I can. Then the second thing is how do you store this inside the app? If you want to store it in local storage, how do you convert or transfer that information from the back end to the front end and save it? And if you want to store it in cookies, how do you save it directly like that? So I'm not going to cover that detail because that is not strictly OAuth related. So that information is covered in the asynchronous JavaScript course. So if you want the implementation detail, let me know. I can point you to it and I can show you some examples as we go along. Right? But not at this point right now, not in this talk. We want to focus on OAuth because time is very tight for this talk. Now, I promise I'm going to talk a little bit about scope. And scope is basically permission. Permission allows you to authorize something. So how each API determines scope is slightly different. Like for example, Google has this very interesting way of using a URL to determine what a scope is. So you kind of when you specify a scope in Google spreadsheet in Google, you kind of have to specify the entire URL. And then GitHub uses something like that, where, like for example, a repo status is a scope which allows you to do certain things. And there is a parent scope called repo that encompasses all the scopes below. So like different ways of specifying scope gives you different permissions. And the thing is, when you specify the scope, they will ask you, like they will show you, in this case, I added a gist and a repo scope. So GitHub actually asks me and highlights it that, this app is asking for this sort of permission. Do you want to let this app have it? Facebook has this toggle where you can do like on-off thing, which is also interesting. So different companies do it differently, but essentially they will still ask and highlight that the app is asking for this sort of permissions from you. If they say yes, then that goes into the whole callback URL thing and everything will be fine. Now, to make this link, we can use something like URL search params to make things a lot simpler. Then you don't have to manually add the question mark and add the end sign on that stuff, and it creates a link like this. So that's the easiest way to do the link. Now let's move on to proof key of code exchange. That's the second method on top of authorization code grant. The easy way to understand PKCE is that it is an improvement over authorization code grant. And the good thing is that it allows you to do OAuth with a public client. But this also, you also have to make sure that the API server supports PKCE, which not many do at this point. Most of them are doing just authorization code grant, and that's the end of the story. So for PKCE to work, you need to add 3 additional parameters. One is called code verifier. The second one is called code challenge. The third one is called code challenge method. A code verifier is a random string between 43 to 128 characters. It should be random because then different people logging in from your app would have different strings and they will not be confused with each other. If it's random, nobody can guess the string and nobody can hack it, which is why it is considered to be secure. Now, for code challenge, it's going to be a SHA-256 hash of the code verifier. And that is the only hashing algorithm. You cannot use any other hashing algorithm. And code challenge method is going to be 256, S256, which stands for SHA-256. Well, there is an alternative, which is called plain, but then code verifier and code challenge will be the same value, so there's no point doing plain. But plain is good for testing when you're starting out. And once you get the idea of things, how things go, you always have to do S256. So that's what PKCE is. And then the question is, okay, how do you generate this random value for the code verifier? Well, it turns out that you can use the crypto from both browsers and Node, except the API for crypto on browsers, API for crypto on Node is slightly different. So in one you use get random values, the other one uses random bytes, and here you need to do a uint32 array kind of thing. The other one, you just convert it to base 64 string straight away. Right. These are some of the API differences that you have to watch out for. Now, to generate a SHA-256 code challenge, it is also quite hard, as I noticed. You kind of have to use text encoder in the browser. Then you do encode, then you do like what crypto subtle digest, whatever that means, and you convert that into the base 64 string with this BTOA and replace some values. It has to be URL something something base 64, I can't remember. Yeah, base 64 URL encode. So that makes things slightly more complicated. And in Node, well, the funny thing is when you create a string, you create it differently and you have to do a different thing to the hash. I'm like, okay, fine. So I did that, and then I realized that this is too hard. This is too hard. So what I did is I grabbed all this code that I wrote together. I put it into a library called PKCE. Basically, you can import npm install Zell Liew /JavaScript, import the PKCE library by adding the /PKCE. Const PKCE await PKCE. End of story. And then you get the code challenge, you get the code challenge method, you get the code verifier, you get an extra state variable, which is used for making sure that the whole thing is secure. So like state is also available in authorization code grant, and it's also a security measure. Yeah, I'll talk more about this in the course. Just focus on giving you a rundown of what this is at this point. So like this is the super simple way of doing PKCE if you ever need to do it. Now, then you need to make a link, right? Because like there's additional stuff. So in PKCE, when you make a link, you need to add 2 additional variables, and that is the code challenge and the code challenge method. So in addition to all the other parameters that you already require for the link. Then what you do is before you send it over, before you redirect the person over, you need to save your code verifier in a cookie. This is a bare bones version. You should probably use HTTP only cookie flag so nobody else can look at it and stuff like that. Talk about it more in the course itself. This is just bare bones. The idea is if you save it in a cookie, when the URL, when the API redirects you back into the callback URL, you can grab this value from your cookies. Right? So when you grab the value from your cookies, what you do is you send it to the token to exchange for to the endpoint to exchange for access token. And that, in short, is what PKCE is all about. Basically, you add 3 additional variables at different times and how you manage that to make sure that, okay, if this value is there, it should be sent by someone legit and not by some random stranger, and that is safe in that way. So now the final thing I want to talk about is the refresh token grant, and it is used to generate access tokens when access tokens expire. And access tokens do expire. For example, Twitter gives you an access token for 2 hours. So imagine if you use Twitter and then 2 hours later you need to log into Twitter again, and then 2 hours later you need to log into Twitter again, and 2 hours later that is going to be bad UX. So essentially what you can do is to request for a refresh token, and when the time is up or when the access token seems invalid, you can use that refresh token that you got to request for a new access token, and the user doesn't know that the access token has expired or anything like that. They are kept away from all of this implementation detail, and they just get happily logged in and continue using your app without any interruptions. Okay, so to get a refresh token, the first thing you need to do is to set an offline scope. So this is usually either offline or offline.access or something offline related. And that is the first step when you generate the login link. When you do that, send it over the authorization code grant or PKCE flow. You get the access token back. If that happens, if you set the offline scope, you will get a refresh token as well. And what you need to do is to save this refresh token in your database so you can query it when you need to. Keep it somewhere safe, not in browser storage, not in anywhere that it can be compromised. So database is the best place to put this stuff. Now, then, what you need to do is when you need to use it, you send it to the same token endpoint. It's usually the same one, unless they decide to write something different. Then the body grant type, you need to set it to refresh token. You need to send in your refresh token, and usually you need to pass in the client ID. That is the standard spec thing. But sometimes people will request for something different, like again, Twitter has this habit of asking you to get the client ID and client secret and put it together in a basic authentication, and you have to convert it into the whole like basic authentication style header in addition to this. So this is the standard one, but again, some APIs would request additional things on top of it. And that's all I have to share with you for today, which is, I think it's quite simple now that we've gone through the whole, like, what's actually underneath the whole OAuth thing. It's not as scary as what most articles make it seem, like once you really get to the nitty-gritty details of stuff. So thank you for being a good audience. Thank you for listening. Yeah.